We talk about time as a resource. We spend it. We waste it. We watch it slip through our fingers as we age. It feels like an invisible river, constantly carrying us forward whether we want to move or not. That exact same vocabulary has quietly slipped into the highest levels of physics. We hear scientists talk about the fabric of space-time stretching, or the arrow of time marching forward. We took poetry and started treating it as physical law. The philosopher Ludwig Wittgenstein warned that language frequently bewitches our understanding. By treating the word time as a noun, we fell into a trap of linguistic entrapment. We took a basic bookkeeping device, a system for comparing changes, and promoted it into an invisible physical substance. Our metaphors build the picture of reality we believe in, obscuring what our own equations actually measure in the lab. This linguistic trap created what we can call the container model. It is the deeply ingrained assumption that reality is a static four-dimensional box. The objects inside simply sit there while the present moves across them, pierced by a glowing timeline axis. But consider what that actually requires. If time is a physical medium flowing through this box, what is it made of? More importantly, how would a clock, a mechanical device made of gears or vibrating atoms, detect a flowing, invisible medium? Treating time as a physical medium introduces a phantom dimension, an ingredient that the mathematical models of the universe may not actually contain. Changism offers a different reading, the ledger model. In this framework, reality is an ongoing field of physical processes changing, and time is the accounting spreadsheet we use to keep track of it. We can audit the history of physics to see how this works, starting with Isaac Newton. Newton mathematically codified the idea of an absolute true time that flows independently of the universe. But in Newton's equations for acceleration, or the laws for thermodynamic entropy, the variable t does not represent a dimension that objects move through. It acts as a yardstick. When an object speeds up, t is the parameter tallying its rate of change. This holds true in quantum mechanics. In the Schrödinger equation, t tracks the rate a probability wave changes state. The tracking mechanism is identical. The math tracks rates of change. Time is the yardstick we use to measure the space between events. It is not the space itself. You might be wondering, what about Albert Einstein? Didn't the theory of general relativity prove that space and time are fused into a single fabric? We often point to time dilation to defend this idea. The popular metaphor suggests that under heavy gravity, or at high speeds, time physically stretches out like a rubber band. Let's look at what the experiments actually record. Time dilation is more accurately described as differential clock accumulation. Physical processes inside systems simply happen at slower or faster rates, depending on their kinetic velocity or gravitational conditions. Clocks do not detect a flowing substance. An atomic clock is a physical apparatus that registers repeatable change. When its environment changes, its ticking rate changes. It relies on counting physical protocol cycles, not tapping into a universal stream. Einstein's math yields correct predictions, but space-time geometry is a representation, a highly compressed map of how changes relate, rather than a literal four-dimensional container. To fix our understanding of physics, we have to perform a language detox. We must strip these phantom metaphors out of our scientific vocabulary. Instead of saying time flows, we translate that into the accurate physical reality. Processes change, and activity is ongoing. There is no flow, only action. When we hear moving through the fourth dimension, we translate that to tracking a trajectory of a changing pattern. We aren't sliding down a corridor. We are tracking how a physical system evolves from one state to the next. Stripping away these metaphors allows us to focus strictly on what we can measure in a lab without breaking the principles of relativity. We can apply this detoxed language to the ultimate science fiction trope, time travel to the past. You cannot visit the past because the past isn't a hidden location sitting inside a container. The past exists strictly as maintained records within the ongoing present. You can't rewind reality any more than you can unburn a piece of paper. When physicists discuss theoretical time machines, they refer to closed time-like curves, or CTCs. A CTC is a hypothetical space-time geometry where a future-directed path loops back to intersect its own past. It describes closed causal accessibility, a complex loop of consequences. not a vehicle traversing a highway. The universe is a field in act, a world of continuous interaction and transformation. Time is the disciplined name we give to the public bookkeeping of that change.